Hello and welcome to this video on how to obtain robust standard errors in the Mplus software. My name is Geiser, I'm an instructor with QuantFish. In this video I want to show you how you can obtain robust standard errors and test statistic in the Mplus software. When would you want to obtain robust standard errors? One application is when you have non-normal data in structural equation modeling. In structural equation modeling, we oftentimes use maximum likelihood estimation to obtain parameter estimates and their standard errors, as well as test statistics in confirmatory factor analysis and structural equation modeling, as well as other types of analyses. Now we know from methodological research that the standard errors and test statistics of parameter estimates in structural equation modeling, when they are obtained with maximum likelihood estimation, can be biased when we have non-normal data. And so one application of robust standard errors is when you want to correct your standard errors and test statistics for non-normality so that you can trust your confidence intervals and also trust your tests of significance for those parameter values, for example, latent path coefficients or latent correlations between variables. So here I have an Mplus output file for a regular structural equation model. This is a very simple model with two factors where we have a latent regression analysis such that factor f2 is regressed on factor f1, and each factor in this model has two indicators. So when we estimate a model like this in Mplus without any further commands, so when we use the Mplus defaults in this analysis, what happens is that Mplus will use maximum likelihood estimation, assuming that our variables are continuous, and it will not correct the standard errors and test statistics for potential non-normality. So in other words, with this kind of setup, you obtain regular maximum likelihood estimates of parameter estimates and standard errors, and they will not be corrected for non-normality of the data. And you can see that when you scroll down in your output file, you can see that the estimator that Mplus uses by default is simply ML, maximum likelihood, and there's no robustness correction here for the standard errors and test statistics. Now, if you do have non-normal data, then this can have an effect on, first of all, your chi-square test of model fit and the associated fit statistics, because those are also sensitive to non-normality. So this means that tests of the model fit may be compromised when you have non-normal data. So you want to address that. And then second, what can happen is that the standard errors for your parameter estimates that you find under model results in Mplus, such as factor loadings and the latent path coefficients and so on, those parameter estimates may come with standard errors that may also be biased, that may be incorrect due to a non-normality. So what you find here in the column SE, those are the standard errors of the parameter estimates, and those are relevant because they are used for significance testing. So our test statistics, the Z statistics that are given in the next column, are calculated by dividing the parameter estimate in the first column by its standard error. And so that results in a Z statistic that is then used for statistical significance testing and to obtain a p-value for that test of significance. In other words, if you have biased standard errors, then also your Z statistic will be biased because it uses the standard error in the denominator. And then further down the chain of events, also your p-value for your Z statistic may be incorrect, and so you may, for example, incorrectly reject the null hypothesis that a parameter is 0 in the population. So you might, for example, incorrectly find that f2 is significantly related to f1. So in this case here you can see that the path coefficient or latent regression coefficient that links F1 and F2 is statistically significant. The p-value here is smaller than 0.001, and so this could potentially be a misleading p-value if you have non-normal data. So how do you correct for that? So how can you obtain robust test statistics and robust standard errors? Going back to our input file here, we can make a slight modification to our Mplus input file by adding the command analysis and then estimator equals, for example, MLM. So MLM is an alternative maximum likelihood estimator that gives you the same parameter estimates as regular maximum likelihood, meaning the same factor loadings, the same latent regression coefficient, and so on, but corrects the test statistics and standard errors in your output. Specifically, the MLM estimator in Mplus refers to the so-called Satora-Bentler correction, which is a correction for non-normality. So this is one way to do this, is by using the Satora-Bentler correction, or MLM estimator in Mplus. And so we can execute that so that I can show you what that looks like when we do this in Mplus with this estimator. And so we can see then that the estimator is now changed to MLM. And when we scroll further down, we also see that our chi-square test of model fit is now slightly different. It has a different p-value because it's been adjusted with this scaling correction factor for the MLM estimator. Furthermore, when we scroll down to the model output, the model results, we can see that the standard errors are slightly different versus the ones that we've seen before for regular ML estimation. Our path coefficient is still statistically significant. So in this case, it doesn't make a big difference here. This data is not affected by non-normality. You can see that the parameter estimates themselves haven't changed. So with MLM, you get the same parameter estimates, but you get different tests of model fit, or an adjusted chi-square statistic, as well as adjusted fit statistics, and you get robust standard errors and robust z-statistics for the parameter estimates. Now, MLM has one downside in Mplus, and that is that it doesn't work with missing data. So when you have missing data and you want to use full information maximum likelihood estimation to include all available data, then you can resort to a different type of robust estimator that Mplus offers. And so going back to the input file, if we change MLM to MLR, then you have an estimator that also gives you a robust chi-square and fit statistics and gives you robust standard errors and test statistics. However, it also works when you have missing data. So that is another option. And that's actually maybe my favorite option when I want robust statistics for an SEM, because that allows me to also have missing data. Now, another option that you have in Mplus for computing robust standard errors that are robust to non-normality is by using the Bollenstein method, which is a bootstrapping method. So you can bootstrap standard errors also in Mplus. And so this works by getting rid of the estimator option and instead writing bootstrap equals, and then the number of bootstrap samples that you would like to create or that you would like to use. In this case, 1000 bootstrap samples. And then in parentheses behind this, you write the keyword residual. The residual bootstrap is the Bollenstein bootstrap in the Mplus software. So let's take a look at how that works. You can see the bootstrap samples are drawn. That's really fast in Mplus. When we scroll down, now we're back to regular maximum likelihood estimation, however with bootstrap standard errors. So now the robustness of the standard errors comes from the bootstrap method. Also, when you look at the chi-square test of model fit, you can see that we get both the regular p-value for the chi-square statistic based on the asymptotic chi-square distribution, or the theoretical chi-square distribution, and the Bollenstein bootstrapped p-value, which in this case is not much different from the theoretical p-value based on the theoretical chi-square distribution. Those don't show any meaningful difference here, which is again because these data here are not suffering from non-normality. And then scrolling down further, we can see again we get standard errors. Now these standard errors are based on the Bollenstein bootstrap method, and once again our path coefficient for the latent regression of factor f2 on factor f1 is statistically significant, even with robust or bootstrapped standard errors. So those are essentially the options that you have in Mplus to create robust standard errors when you have data non-normality. There's also an option called type equals complex when you have multi-level data or hierarchical data. So for example, individuals nested within companies or students nested within classrooms, then that type of data nesting can also lead to biased test statistics and biased standard errors. And you can address that in Mplus by using type equals complex in the analysis command, which then also produces robust standard errors that are robust to clustering of observations. I hope you found this video useful to learn more about robust methods in structural equation modeling in the Mplus software. If you did, please subscribe to this channel and check out the description for additional resources, including courses on SEM and related techniques that we offer through QuantFish. And I'll see you next time.